We're going to do a couple of sample problems in this part of the lesson and to consider energy use, and we'll look a little bit at how your home energy consumption is calculated and the difference between the different types of units. So here I have an example question, and it says that a 27-inch iMac computer has a power rating of 145 watts. If the computer is on for 5 hours, how much energy does it use? So I'm looking for energy here in joules, so I need to write out my given and required. So power is 145 watts, time is 5 hours, but since we're working in watts and joules, we're going to need that in seconds. And we have 60 seconds in a minute and 60 minutes in an hour. So that's 5 times 60 times 60. So this is 18,000 seconds. And energy is what I'm looking for. And we know that power is equal to the change in energy or energy use over time. And that means that we can rearrange a little bit and solve for energy as power times time. So 145 watts times 18,000 seconds would give me 145 times 18,000. So we get 2,610,000 joules, because watt times seconds is joules. So therefore, the computer uses 2.61 times 10 to the 6 joules, or we could even do 2.61 times 10 to the 3 kilojoules. Seems like a lot of joules. But we can also measure energy in kilowatt hours. So it doesn't have to be in joules, it can be in kilowatt hours. And we're actually billed for energy use. Your home bill will be billed in what is known as kilowatt hours. So how much energy does the computer use in kilowatt hours? We've already calculated it in joules. Let's take a look and see what that would mean. So this time I'm going to need power in kilowatts instead of watts, and my time will just be in hours. So this time it's 0.145 kilowatts times 5 hours. And it turns out that that is 0.725. So 0.725 kilowatt hours. Looks like a much more manageable number than in joules, right? Our joules, we were up in the millions, and here we're still looking at a decimal. So this seems a lot more manageable, and that's one of the reasons that we're billed in kilowatt hours. We get much more manageable numbers even for something that is of small use. So if your energy cost was even as high as 10 cents per kilowatt hour, well, this would only cost you then 7 cents. So 7 cents to have your computer on for 5 hours. Doesn't seem like a lot in terms of money, but 0.725 kilowatt hours is still quite a bit of energy. So if you leave your computer on for 5 hours when you don't need to use it, you are using up quite a bit of energy. And I just want to look at the comparison between joules and kilowatt hours, because the other way to do it was we could have converted. So we could have used the answer we got previously and converted the unit straight from there. So we know when we look at joules, right? So when you were looking at joules before, joules are watts times seconds. Okay. And we know that a watt is joules per second, right? So that makes sense. So if we look at energy in kilowatt hours, well, energy in kilowatt hours, so that would mean my energy over here was in kilowatt hours, and we got it by multiplying the power times the time. But the power was in kilowatts, and the time was in hours. So it seems pretty straightforward here. So in order to go from a conversion from joules to kilowatt hours, what I'm essentially doing is converting from watts to kilowatts. So I'm going from here to here, and then from seconds to hours. So if I wanted to convert from watts to kilowatts, then I need to do my conversion factor as 1 kilowatt over 1,000 watts, right? So this is my conversion factor. That's this part here is this conversion factor. And we'll do the conversion factor for seconds to hours. I need hours on the top then. And there's 3,600 seconds in an hour. So that's my conversion factor for this part here. So essentially, I could have gone from my answer before, which was something like this. So I could have then used the conversion factor here, which simply means I'm doing 26, 10, 0, 0, 0, divide that by 1,000, and then divide that by 3,600, and look at that, we get the same answer. We end up with 0.725 when you convert to kilowatt hours. So if you already know the joules, you can convert to kilowatt hours. If not, you can calculate like we've done here. So now you've got a couple of different ways to do it.